Alright, I think I've disconnected everything I need to, but the problem is now you can't get the pots out because the board's in the way, and you can't get the board out because the pots are in the way. So I guess what they did was install the pots, or install the pots and the board at the same time by flipping the board up this way, and then installed all the power section, the output section stuff afterwards, which has now locked the board in. So now I'm going to have to remove the solid core heater wires going to the output valve sockets, which is another bad idea, because there's no flexibility in it. So now we can't lift the board, and we also risk possibly damaging these pads when we remove it, if there's any like burr from cutting the bottom of the wire, which may have happened. Or if they're folded over at all, which would be another idiotic thing. But hey, we're working on a Mesa boogie, so idiotic's the name of the game. No, okay, so they were only just passing through the top of the PCB, so that's lucky. Alright, so heaters are disconnected to the output valves now, so we shouldn't have a rigid connection to the chassis once we pull the standoffs through. Now, speaking of the standoffs, often it's easier to remove them from the chassis side because they only have a small little dome on that side, whereas on this side you've got probably at least half an inch high, so you'd have to clear this before you could do anything with the circuit board, and you risk snapping them off. So we don't have to lift the board as much if we remove them from the chassis side and leave them attached to the board. That's a lesson I learned the hard way, along like every other lesson on Mesas. So these only have to go through by about 4 or 5 mil, and every little bit helps. Ideally, for your flagship amp, you wouldn't use plastic standoffs. Yeah, you'd use a screw and a post, but you don't get what you pay for with Mesa. Alright, let's see how we go now. There may be a little bit of swearing. If you're sensitive to that, well, you can fuck off right now. I might. So we're bumping into a screen grid resistor, and they are all quite out of whack. So I'll be replacing them anyway with some wire wounds or metal films. So we might just get at least this one out of the way to start with, so we can actually get the board back. This is just so fiddly working on these things, man. Alright, so everything's in the way of everything. Makes you wonder how they could make any money manufacturing these things, because they're certainly not efficient to build by any means. You know what? This isn't going to work. There's not enough room to get the pots out. The whole board wants to go back into where all this tower bullshit is back here. All the point-to-point crap around the output valves. So I think we'll just remove them completely, and they can get put back in later. So there's another hour in that, because I can't move the board back far enough to get it out. Can't move the board back far enough to get the pots out, and the pots are stopping the board from lifting. So I might just try. I wanted to take the pots out along with it, because I want to try and rewire as little as possible, because it's very time consuming figuring out where everything goes, particularly with incompetently written documents. Alright. Horrible freedom. So we didn't have to remove the output valves. I just had to jiggle stuff a bit more and broke a few connections, and but yeah, they probably would have broken anyway. A lot of these has to be redone, so no big stress there. So this is a typical example of the quality of work that was in here, that I was welcomed by. Tack soldered everything. It's hanging on to a very small cross section of that pin. If we bend that a little bit, you can see there's movement there, and off it pops. So that's why you don't tack solder stuff, because if you do, I'll call you out. But yeah, you got stuff like that leads just asking to touch the other one. Everything's uninsulated. Slide over to this pot here, that unshielded one's just asking to touch the one next to it, and terrible soldering again. Whoever did this can't solder. Here's another beautiful example of their workmanship. Just It's melted so bad that there's bits of jacket actually floating on top of the pool of solder. So when they couldn't get a good connection, they just created another blob and soldered to that, and oh, you need another blob, so they just add a blob and just tack to that. Just ridiculously bad work. So I'm not happy with any of this, and I can't let it go out looking anything like this. So I think I'm gonna order some new pots if I haven't got any, and redo this whole lot, redo it all, because this is absolutely shocking work. It's just examples like this of burns everywhere, melted insulation, even with the internal wire exposed. And you can see here, despite the poor, barely wetted solder connections, they've managed to melt the jacket a good 1/2 to 3/4 of an inch up the lead by overheating the wire. Don't ask me why you'd group them together and then just use one pole here. Don't know, must have been some afterthought, or maybe they were tweaking some mod, some magical mod, I don't know. So I'm really tempted to just snip away everything here and just literally start again. The only thing holding me back is the lack of documentation and the shitty schematics, making it difficult to map the thing again and figure out the layout. But having said that, this is probably wrong anyway, going off all the other shitty work. So I don't know, let's just do it, eh? Might accidentally make it a better amp. So every wire that's got melted insulation needs to be replaced. So all these clips have to come off, and I need to figure out what's going where. But as you can see down there, everywhere I look, there's just really bad work and shitty soldering and just totem poled solder blobs in some vague attempt to hold everything together. Curiously, someone has swap the wires over, so you can see the black and white. So black is normally active and white's neutral in the US color code, but that left hand pin looking this direction is actually active. So they've realized that, well, I'd like to give them the benefit of the doubt, they've realized that the the neutral was fused and then going to the voltage selector, and they've swapped that around so the active is fused. So now the white wire is the active, that goes to the fuse, and then to the main selector switch. You can see the MOV there to damp spikes. That's just silicon to the switch, and the neutral is what's actually switched down there on the power switch. And you can see there, because they couldn't get all those wires through that eyelet, they've just made like a turret out of the thickest wire and then wrapped the others around it. So champions, this is how I'm working on this thing. I'm noting down where things were connected. Some of the terminals have numbers written on them, although being Mesa, they've got duplicate numbers over the other side, but at least that bank of holes are numbered sequentially. So I can note down what went to what number, double check that on the schematic, and then draw a little circle next to it with what pad it used to go to. And that's also the case for the pull switches, which at the moment are a massive mess. So just carefully noting down everything and taking photos is the key to not being super confused when you try and put it back together. Ideally, you don't want any long-term projects. You want to get the thing completed while it's fresh in your mind, because coming back to an amplifier a month, 2 months later even is a bit of a nightmare, because you can't remember anything. It's really hard to reconstruct your thought patterns and familiarize yourself with the amp when it's all in pieces. So despite you know, some of my customers' beliefs, I do amps as quickly as I can just to keep everything fresh in my mind. Sometimes you got to wait for a part or whatever, but you know, I do stock a lot of stuff too, champs, but you know, a lot is never enough. And the heater balance resistors are carbon comps, just mounted down on the board there. They burn in a very non-graceful way. I'll link you the video just up above right now, showing different failure modes of resistors when I tested them overloaded. And carbon comps are one of the least graceful ones that literally catch fire and leave smoke everywhere. So I'll replace them with some fusible resistors, lift them a little bit off the board. So if they fusible resistors almost instantly go open circuit with no real light show, but just in very case that they try to short out to that trace underneath, I'll lift them off the board by a touch as well. Alright champions, she's repopulated, all the dumb shit's removed. Oh, I've got to change those carbon comps because they're pretty out of whack to each other and out of tolerance. I found some more accurate schematics that some crazy person has drawn from scratch online, and that helped me out with a lot of it, where it just didn't make sense because I had nothing to go off because it had been so heavily modified when it came in. But now we're pretty much the stock circuit. I'm going to get this board back in, get the pots mounted on the front panel, and get everything wired up, and we'll show you the finished result in the next video and give you some sound samples. So we'll stick to a 3-part video for this one. Thanks for everyone following along. Thanks for your patience. I know mine was tested with this amp.